Good afternoon, we're Team Spectra. We're going to talk about the paper application of machine learning in credit risk assessment. First of all, it is important to understand that the main objective of this paper is to create an accurate model for evaluating credit risk in the banking sector. After that, the paper in an introductory manner discusses what is machine learning, such as computational automatic learning that allows the computers to not only behave but also learn like humans through a continuous improvement through data, daily interactions, and also observations, where the banking sector and finance sector are two of the main fields where machine learning is involved. Also, the paper starts presenting as an example the student default in America in order to emphasize how default is a really big issue not only for the finance organization but also the economies, suggesting the use of classifiers to categorize applicants based on this pattern and also to predict whether they might get into a default or not default. The paper also introduces three models, being the first one, the artificial neural network model and the logistic regression model, a solution for the credit risk assessment, and a third model based on the support vector machines for credit risk assessment, where this paper analyzes the three models in order to have a model that may identify potential defaults.
For the proposed model, we will be using dataset from Lending Club. It will be then binarized, in which 1 represents people who avoided default and 0 people who didn't. Then the dataset will be filtered to remove invalid data. And then we have to do something about the class imbalance. And our sampling technique will be applied to the minority. In this case, the minority is people who defaulted. Then the dimensionality reduction will be used to reduce the variance and increase the accuracy of the model. And then after the proper parameter tuning and having a good classifier, the results can be properly analyzed, and we can then choose which model was the more effective.
Now, the author talks about two classifiers that can help optimize the process of our machine learning methodology. For example, the purpose of the five-fold cross-validation is to verify we have independent results on data outside of the training of the model, because usually the model overfits its optimization to a training data. Think of it as training somebody through guide exams and then presenting them to actual exam at school. There is also the RFECB, which returns the optimal amount of features for the performance of the model. In this case, it worked well. There are also some neural models that can provide just as multi-stage reliability-based neural networks to the usage of artificial intelligences, which are mentioned in the comparison of the models. Eventually, we care about our accuracy or the scale of the model to a relevant size of the data group.
The research focused on credit risk assessment using machine learning methods. The study concludes that supported vector machines outperform tree-based and regression models, despite initially excluding neural networks to the complexity. The potential benefits with larger data volumes are faster for inclusions. The paper highlights the model approach to identify loan defaulters, showing the impressive results from the Lending Club dataset. This model offers valuable insights from credit lending institutions and encourage transparency and profitable operations in dynamic economic landscape.